Right. So our last example is with moles, but of course, in real life, we weigh out moles in some type of way. The most common type is to use mass, right? So let's take a look at a question. What is the theoretical yield of iron if 32.5 grams of aluminum is reacted with 52.3 grams of iron oxide? And then we're given the chemical reaction for it. So 2 aluminums combine with 1 iron oxide to form 1 aluminum oxide plus 2 irons. So let's think about this for a little bit. What we want to do is similar to what we did last time. Take a look at each component, calculate its theoretical yield, and then pick the smaller one. So we can go ahead and just start off with the aluminum. If we have this much aluminum, how much iron oxide could we form? So we start off with the 32.5 grams of aluminum. Of course, our goal is always to get to moles of A, in this case, moles of aluminum. So we can use that, the molar mass of aluminum, which is 26.981 grams per mole, which we can grab from the periodic table. After that, when we're at moles of A, we use our stoichiometric coefficients to go from moles of A to moles of B. According to our chemical reaction, for every 2 aluminums, we get 2 irons. And then after we go to moles of iron, we want to know grams of iron, right? Generally, theoretical yield, it doesn't say grams in this case, but most often we deal with grams. So then we use the molar mass of iron, 55.845 grams per mole. Everything else cancels out and left with grams of iron. And I get 67.3 grams. So there's the first component, and then we just repeat the same thing with the iron oxide now. So we start off with 52.3 grams of iron oxide. And then we take a look at the molar mass of iron oxide, which according to Google is 159.69 grams per mole. Then we want to use our mole-to-mole relationship from our balanced chemical equation, and that tells us for every 1 iron oxide, we get 2 irons. After that, we can use the molar mass of iron. Right, all of this stuff gets canceled out. And then we plug this into a calculator, and I get 36.6 grams of iron. So I have enough aluminum to make 67 grams of iron, but I only have enough iron oxide to make 36 grams of iron. So then this is going to be our limiting reagent, and this is going to be our real theoretical yield. Right, so we can only produce 36.6 grams of iron, and the iron oxide is the limiting reagent.